calculating speed and density, and I already gave you the correct equation for speed, so you can go ahead and calculate it, but the density can still be calculated without the speed value, although speed is required to finish your calculations. Okay, so the speed should be calculated, but I will move on to calculation of density. Okay, thank you, Zain. Okay, so this will give you the average density for the freeway. Yes, so how much is that? Okay, so is this all of it in passenger cars per, this one is passenger cars per mile. The speed was miles per hour and the flow was passenger cars per hour. Okay, this is according to the units which you have put earlier. Moving on, so this is the end of this topic, which was on the uninterrupted flow facilities. Now we'll move on to the next one, which is the interrupted flow facilities. So who can remind me about the difference in interrupted and uninterrupted flow facilities? What was the difference? Yes, what's the difference between interrupted and uninterrupted flow facilities? Dana, Zainab, what's the difference in them? No one? Okay, you can find out later on. I will move on here. So interrupted flow happens at the intersections, and we are talking about at grade intersections because even the uninterrupted flow facilities have interchanges with ramps. So at grade intersections happen when two or more road cross at the same point, and when these roads are crossing, the vehicles can uh, come into contact with each other, and the points where this contact happens are known as conflict points. Okay, so conflict points are those points where vehicles belonging to different directions come into contact with each other, and they can be of different types, which you can see in this figure. Okay, so they are crossing, diverging, and converging. Okay, the crossing ones, if you see, vehicles are crossing in different directions, the blue ones. Okay, so for example, this one or this one, the first one. Okay, so this is between a vehicle going uh, westwards and the vehicle which is coming southwards. Okay, so this one and this one, so it's a crossing between them. And what about this one? This is for the vehicle which is turning left from here, and the vehicle which is going straight from here. Okay, and so on and so forth. So in this direction, basically, sorry for that, going northwards. Okay, so this left turning and this straight movement. So this is called crossing. Diverging is when two vehicles are coming from the same direction but they are going in different direction ahead. So this green one, for example, both of them are coming from west, but one of them will continue towards east and the other one will take a turn towards south. Okay, and this one, again, both of them coming from the west, but one of them will take a left turn, the other one will go straight. Okay, so this is diverging. And then we have the converging ones, where vehicles are coming from different directions and converging into one direction. So you see the orange one here. Okay, so a vehicle taking a right turn and a vehicle going straight from west. Okay, so they are converging here. This one, a vehicle taking so a vehicle which is which one is that? Is this one? Okay, where the vehicle which is coming from this direction, I believe, yes, this direction. Okay, so vehicle coming from north and vehicle coming from west, so they are converging here. Okay, so this is for a typical four-leg intersection. Okay, so you can count the number of crossing and diverging and merging here. Okay, they are given here, total 32, 16 for crossing, 8 for diverging, 8 for converging. And then at the roundabout, you see there is no crossing here, because you don't cross, you come onto the roundabout in all cases. So you have either converging or diverging only. There is no crossing, because you cannot go straight in any direction, or you cannot go from one direction to the other without coming on the roundabout. Okay, so no crossing. Then diverging and converging only happens when you enter and leave the roundabout from each direction. So from each direction you can enter and leave. Okay, so when you enter, you are converging. When you leave, you are diverging. Okay, so every direction has these two, converging, diverging. Okay, so 4 directions means it will be 8. Okay, each direction has a converging and diverging. Okay, so if you have seen this example, or if you compare between these two examples, you will see that all these crossing points can happen if I am not using the roundabout. When you use the roundabout, the conflict points reduce. Okay, so this is the function of a traffic control device. What is the traffic control device? The device which we put at the intersections to regulate the flow of traffic, to tell the vehicles when and how they should move from the intersection. Because if you leave it to the drivers, then something like this can happen. Vehicles can come from different directions at the same time. Okay, so that's where we need the traffic control devices to be to be at the intersection. Okay, so we need to assign the right to move, what they call as the right of way. Okay, So vehicles can move in which direction and at what time. That is the right of way. Okay, so the control device gives the right of way to different vehicles in different priorities, in different order. Just the most obvious example is a signal. So signal has timing for each direction, right? And that timing is in a particular order. So vehicles can move according to the timing given by the signal in the order which is shown by the signal. But even the other devices, they have this concept. Okay, so if you are on a roundabout, okay, if you are on a roundabout, then you have to, so what is the order of the movement on a roundabout? Okay, you have a vehicle which is on the roundabout and you have a vehicle which is entering the roundabout. Which one has the priority? The one which is on the roundabout or the one which is entering the roundabout? Which one has a priority? Yes, tell me. Which vehicle has a priority on the roundabout? The entering one or the one which is already on the roundabout? Will the vehicle on the roundabout wait for the entering one, or will the entering one wait for the vehicle which is on the roundabout? Yes, anyone? Zainab Abdul Azim, Zainab Ali, Dana Ali. What's the answer to this question? Yes, it's an easy question.
On
Yes.
the roundabout.
Yes, the one on the roundabout has a priority. So the priority is the order. Okay, thank you. The priority is the order. The one which has the priority is higher in the order, and the one which is lower in the priority is lower in the order. Okay, so every control device has an order, a priority attached to it. Okay, so when you use a control device, obviously, as this one shows, the number of conflict points are reduced. So it was 32 here, reduced to only 8. Okay, so it is to a quarter, only a quarter of the actual number of conflict points. Okay, so what are the examples of traffic control devices? We have signals, we have yield signs, okay, give way signs, the inverted triangular signs, okay, the give way or the yield sign, we have stop sign, and sometimes we use flashing beacon as well. You may have seen flashing beacons for pedestrian crossings. Okay, I have seen near one before the bridge at Sitra. Okay, not the Sitra bridge, after Sitra bridge, before Alba. Okay, so we have the flashing beacon there, and there's one in Isa town as well. Okay, so the yellow signals which keep on flashing. Okay, so this is also a type of traffic control device. That flashing signal is also a type of traffic control device. And then we have other intersections which have so little movement, they have so less traffic that we can use them without any control device. Okay, the volume on that intersection is throughout the day very low. Okay, so I'm not talking about low in few hours of the day, I'm talking about low most of the day. Okay, so 22 23 hours of the day the volume is very low. Then we can take a chance that we leave it without the traffic control device. And when we say low volume, which we mean the combined volume from all directions. Okay, so even so there are multiple directions here. So let's say the volume from this road is very low. but this road is half of the day very high. Okay, so even if one direction has high volume, I should use a traffic control device to make it safe for the other direction. Okay, so but in the case where the combined volume from all directions is very low and it remains low throughout the day, then we can keep it uncontrolled as well. Obviously, in those cases, we are saying that the driver will use their judgment to cross the intersection. Okay, you have seen these types of intersections. There are many on local streets in Bahrain. Okay, like in all local streets, we have these type of intersections where you don't see signs or signals there, and basically the driver looks at the other direction. If it is free, he will move, otherwise he will not move. Okay, in Bahrain we sometimes use a hand signal or flashing of the lights to indicate the other driver whether he or she should move or not, right? So they have these signals in other countries as well. Okay, if a driver is coming from one direction and he wants to tell the other driver I'm coming, or the other driver wants to tell him that I will wait for you, they use these type of signals. Okay, so there's a usually traffic signals are not preferred on small streets. Traffic signals are not preferred on small streets because they usually create more delay. Okay, especially for low traffic conditions, because the signal remains red and yellow, and in during that time the vehicles need to wait. Okay, so you are forcing the vehicles to wait, and every time the signal is red, there could be a lost time, meaning the time when they are waiting and there is nobody on the intersection. So this happens many times during the day on a signal. So the signal is bound, or the driver is bound by the signal. He cannot move until they have the signal turns green. Okay, so that's why we go for the signal as the last resort, as the last option. So we try to use the other types of traffic control devices, stop sign, yield sign, uncontrolled, before you go on to the signal. Okay, and we will later on discuss why when in some cases signals become necessary. So we'll discuss all these cases, but just to give an idea that in Netherlands there's a town, and there are other cities in Netherlands as well. Even if you go to Amsterdam, you will not find many signals. It's the main city, it's the capital, but you will not find many signals there. Okay, and so this Drachten town is a town of low population, 50,000 people. Okay, low from like standards of the world. Okay, so this particular traffic engineer Hans Monterman, he came up with the idea that why don't we remove the signals for this small town, and then we see the effects. And he found that the effects are good, the safety was not disturbed, and the traffic flow was smoother, like the delay was less. Okay, and that's why they have started adopting the same strategy. What's the strategy of removing the signals, avoiding the signals? Okay, so this guy Hans Monterman came up with this idea that let us avoid the signals as much as possible. Okay, so most of the traffic control devices, they are like I mentioned, the order, the priority. Okay, so when you have the priority, the other guy is waiting for you. So this is the amount of time which is for that movement which has the priority. So traffic control devices, they assign a particular time to a movement. This is the right of way. Okay, the time is the main problem, right? If vehicles enter at the same time, that's why we had the accident. Okay, so the traffic control devices, they give priority. Priority means any vehicle can enter the intersection at a particular time. Okay, whether the time is given by the signal or the time is because of the priority. So that also means that you are not using the full time, the full hour. Okay, so let's say if one direction has a capacity of 2000 vehicles per hour per lane. Okay, but this capacity when this highway comes to the intersection, the full hour is not available. So if it was serving 2000 vehicles in 1 hour on the highway, when these vehicles come to the intersection, they cannot pass from the intersection as 2000 vehicles per hour. So they will be less, okay, because some of the time has to be for the other movements. So this is how the capacity reduces. And I have already told you that in case of a signal, this reduction is higher. Okay, so this is the effect of assigning priority, that you are not able to make use of the complete time for all directions. And but why are we doing it? For safety and efficiency. Okay, safety is very obvious. Okay, vehicles enter at the intersection same time, they will collide, there will be a crash, there will be an accident. Why efficiency? Sometimes you may have seen, if you have taken classes in Isa town, if you have come on the highways in the peak hours, sometimes you will find that somebody has entered the intersection, but he cannot find the space to move forward because the highway is blocked. So this guy is now blocking the intersection for the other movements as well. Okay, so let's say somebody entered from here and now he is standing here. So while he is standing here, even this movement is blocked. Okay, and this left turn is blocked, and this and some other movements. So one guy which is stuck on the intersection is blocking the other directions as well. So this is how the traffic control device is required for efficiency as well. So traffic control device will eventually reduce the time available for a movement, but it becomes important and necessary for safety, first and foremost for safety, and the second one is efficiency. So the vehicles do not get stuck or do not block the intersection. That's why you have the yellow signal, yellow box as well, right? The yellow box which we use at the intersection is because of that, so that people don't block the intersection. Okay, this is a diagram which shows you the capacity of different types of intersections. Now keep in mind, this is a comparison between the intersections. You cannot say that the capacity of the signal will become more than the capacity of the normal highway. It cannot happen, okay, because of the timing issue I already told you. So this is a comparison between the intersections. So don't compare any of them with the highway. Okay, so when you are using no control device, it has low capacity. So I told you we do it at local streets, okay, small streets with low volumes. Then if you are using yield signs, the capacity increases. If you are using small signals, the capacity further increases. Now this is interesting. Using a roundabout on smaller intersections is more beneficial than using a signal. So at small intersections, using a roundabout is more beneficial. The signals become necessary when you have a big intersection. On big intersection, the signals become necessary because vehicles will need time to move. In that case, the capacity is higher. Now, why the capacities are increasing with the control device? So without the control device, what happens? You are coming to the intersection and you will look and you will be more cautious because you don't know when to move. You are just depending upon the judgment of the other driver and yourself. So your movement will be slower. You will take more care. But when you have a control device, you know when to move. So at your particular order, you will move at high speed. Okay, so a guy who is in the roundabout will move higher at higher speed. The guy who has the green signal will move at higher speed. Okay, obviously if all of them have to cross the intersection. Okay, but when they have a particular control device, their speed becomes higher because their confidence is higher that this is my time, this is my priority. On signals, it is much higher and compared to a yield device and so on and so forth. Okay, so traffic control device need or have some conditions which dictates when they should be used. Okay, and these conditions are known as warrants. So what are warrants? The criteria which you follow for using a particular type of traffic control device. Okay, so if I'm going to use a signal, I will look at the criteria when to use a signal, and these criteria involve traffic volume. If so the volume is this much, we can use a signal. If it is below this much, we should use a stop sign, and so on and so forth. And some of the criteria depend upon crashes, accidents. If you have accidents more than this, then this device is used, and so on and so forth. And some of them depend upon pedestrian activity, pedestrian volumes. Okay, so traffic control devices have criteria. These criteria are known as warrants. When you fulfill these warrants, then a particular traffic device can be used. If you don't fulfill them, then that particular device should not be used. Okay, but these warrants are just indications. Warrants or criteria are indications that a device should be used. In the end, it is the decision of the authorities and the engineers. Okay, so a warrant or a criteria is not something which always results in installing the device. Sometimes the authorities or the engineer, using their judgment and using their experience, may do something different. Okay, so this is possible. Now, from where do I find these criteria, the warrants? It is given in a manual, which is called as Manual on Uniform Traffic Control Devices, in short MUTCD. So MUTCD contains the conditions for all traffic control devices. Okay, so according to the manual, the conditions are, or the warrants are divided into three types. Okay, the warrants or conditions for traffic control devices are divided into three types. You have shall, should, and may. Okay, shall means conditions, if they are fulfilled, the traffic control device must be used. So shall means it must be used. Should means that using them is highly recommended. Okay, should conditions, if they are fulfilled, that means it is highly recommended to use a traffic control device, but you may not use it. It's not necessary. It's higher, it's lower priority than the shall conditions. And may conditions, they are 50-50. You may use it, you may not use it. Okay, so the conditions, warrants which are given for traffic control devices, they are divided into three types: shall, should, and may. Shall are conditions, if they are fulfilled, the device must be used. Should are conditions, if they are fulfilled, then device should be used. And may are, then the device may be used. So shall has the highest priority. If they are fulfilled, the device must be used, and so on and so forth. So the process of taking a decision for installing a device goes in these three steps. First of all, you collect data from the field about the warrants, the conditions which are given in the warrants. They require some data. Then you check these conditions or the data against the warrants. So for example, you counted volume on the intersection. Then you go back to the warrants, and then you check what is the limit of the volume given in the warrants and what is your actual volume. You compare between them, and then in the end you use your engineering judgment to decide whether I should go with the warrant or not. Okay, and you may do some other studies, on the basis of your comparison. So I compared the volume with the warrant. The volume was less than what the warrant is saying. So according to the warrant, according to the condition, the device is not required. But you are still facing lot of delay on the intersection. So you may do an additional study to know the reason. Okay. So if the warrants are met or not met, on the basis of that, before you go on and install the device, you may do additional study to further know what is actually happening on the intersection. Okay, and sometimes a study is done after installing the device. So a warrant says install a roundabout. So I install a roundabout. Then I need to monitor the roundabout, monitor the movement through the roundabout. Is it solving the problem or not? Or sometimes I study is before installing the device, and sometimes I study is after installing the device or follow up. Okay, so we will be going through these warrants. Okay, the first warrant we will go through is for the yield sign. Okay, so these conditions which you see in the table are from the manual, and these conditions are all shell conditions. Okay, and so yield sign, when you have a roundabout, the yield sign is assumed to be there at the entry. So all entries to the roundabout have a yield sign. Okay, or they are default, like you mentioned that we need to give the priority to the vehicle which is already on the roundabout. So there's a yield give way. Okay, so these the conditions which you see here, they are other than that. So on a roundabout it is already there. When you install the roundabout, the yield sign automatically becomes at the entry. So these other conditions, so these conditions are for the other cases without the roundabout. Okay, so if you have a street or a highway where a stop sign is not required. Okay, so you check the condition of the stop sign and it was not required, so you may go for a lower warrant or lower traffic control device, which is the yield sign. Okay, the second crossroad of a divided highway. Okay, let me make it over here. So you have this. Okay, and this one has a median. So I'm coming from here. Okay, we don't normally do that, by the way. Okay, so if I'm coming from here, okay, and then I have so you may have a yield sign here, and then you may have another yield sign here as well. Okay, so if the median is wide enough, okay, so this median is wide enough, the vehicle can come and stop here. Okay, it will not disturb this traffic. Then we can have a yield sign here as well. Okay, or in some cases you may have a highway and you see a side road here. Okay, so this is the main highway, you have both directions here. Okay, and then there's a side road here. Okay, so again there could be a yield sign here and a yield sign here. Okay, so the point is, when you are moving from one part of the highway towards another part, like crossing one part of the highway and then crossing the other part of the highway, either because of a median, so you're crossing one direction and the other direction like this, or you are crossing the highway and then you're crossing the side road as well, service road. Okay, so you may have an extra yield sign, but in both cases we need the median or the divider to be wide enough to have a vehicle here. So if a vehicle stops here, this space should be wide enough for the vehicle to stop without blocking this road. Same thing here, if a vehicle stops here, this should be wide enough for the vehicle to not block this road. Okay, so this is very important. So this is another case of a yield sign. Then we have a channelized turn. Okay, so let me remove this. So you have a right turn here, and for the right turn they have made a separate island. Okay, so I'll take the right turn from here. Okay, and this is the highway for street. So when I'm making the right turn, I have to merge into this lane. So you may give a yield sign here for people, because if there's somebody already in this lane, then this guy needs to wait. Okay, so you may provide a yield sign over here. Okay, then the case of engineering judgment, as I told you. So the engineer studies the intersection and he feels according to his judgment, or she feels according to her judgment, that a yield sign will solve the problem which is happening in the intersection. And the problem could be people are getting stuck in the middle of the intersection, there are many accidents at the intersection, or anything. Okay, so this is based on the judgment. And then we have uh, the entry of a merge movement. Okay, and where the again the judgment dictates that putting a yield sign will be better. Okay, what we mean by a merge movement? So merge movement is similar to the right turn, but it is something like this. So there is one highway and it's happening in this way. People are coming from here, people are coming from here as well. So this is merge. So you may give them yield sign, one of them yield sign. Okay, if you feel that the side this mainly happens when the side distance is not enough, or the people are coming at very high speed, so they will not get a chance to look at the other guy if they just keep on coming without. So you put a yield sign there, so they will proceed with lower speed, they will proceed with more care. Okay, so you may use a yield sign here for the merge movements as well. Then we have the roundabouts. Okay, so roundabouts are very popular. They were very popular in Bahrain as well. Now they have reduced. Okay, but in the other countries they are becoming popular again, and the reasons are they improve safety. I showed you this at the start. So the conflict points are completely removed. Okay, 75% of the conflict points are completely removed. They do not exist. Okay, so they improve safety. Then they are adaptable to changing traffic volumes. Okay, now on other intersections, if you put for example a stop sign or a yield sign in some other year, let's say after 5 years, 6 years, the side where you put the yield sign has higher volume now than the other side, but you give priority to the other side. Okay, so you put a yield sign or stop sign for one side and the other side has priority. So when this side, which has a yield or the stop sign, it has more volume, now you have to go and change the sign there. Okay, you have to go and change the control device. But with the roundabout, this change in volume does not need any changes in the roundabout. The roundabout can still function, okay, without changing anything, because the priority is when you don't see anybody else from coming from the other side. Okay, so and this can happen during the day as well. So you gave one side priority on a signal. Okay, and now this side in the evening has very low traffic, so you gave this side more timing in the morning. Okay, but you cannot continue with the same timing in the other hours because this side will have less volume. So I need to go and program the signal for different timings. But on a roundabout, you don't have to do this. When the volume of one side decreases, the other side automatically gets more chance to enter the roundabout. Okay, so this happens automatically. So there is the adaptability of volumes throughout the day as well as in different years. Then roundabouts look more beautiful than normal intersections. You can do you can make them grassy, you can do plantation on it, you can have monuments on it. Okay, we have some famous roundabouts in Bahrain, right, which have these monuments, these things over them. Okay, can you give me a name, any famous roundabout in Bahrain? I don't know what to do. Maybe there's a problem with my net connection today. I don't know. You have to bear with it. So any famous roundabout in Bahrain? I'm asking this because most of the remaining roundabouts are now the old ones. So they have something attached to them, some monument or some important thing. So can you give me any names here? Yeah, the Rifa roundabout, okay, also known as the clock tower roundabout, right? So it is famous because of the clock tower, and it is decorated at national days and so on, right? So there goes the point about aesthetics. Then at the roundabout, vehicles enter and leave as they are turning. So when you enter the roundabout, you are turning into the roundabout, and when you leave, again you are turning out of the roundabout. Okay, so at turning, your movements decrease. So there is no straight going in and out, right? You are always turning. So your speed is always lower. So even if there is no conflicting movement, you are the only driver entering the roundabout, but you will not do it at fast speed because you have to go on a curve. So speed is lower. So lower speed makes it safer for the pedestrians to cross. Okay, so roundabout has the safety of the vehicles as well as safety of the pedestrians and cyclists because of the lower speed. Okay, so in US when they did that, when they compared between the roundabouts and other intersections, they found roundabout have 48% less crashes, and I already gave you the reason. Okay, because of the conflict points as well as the speed. And the same thing is observed in Bahrain as well when they collect data on different intersections. You will find that the top 20 intersections which have accident problems are signals. Roundabouts come after the top 20. Okay, this the data is from an old year, so just to give you an idea, a comparison. Okay, so the number of signals are more in the intersections which have a safety problem as compared to roundabouts. Now you would imagine it should be the other way around, because signals, the light is green, you move, the light is red, you stop. It's very simple. But the roundabouts are more efficient in terms of safety because of removal of the conflict points and because of lowering the speed of the vehicles. Okay, so because of this, these mainly the safety advantages, many authorities are considering roundabouts as their first priority. Now the graph which you see over here, this graph tells you uh, when the roundabouts can be used. Now roundabouts can be single lane or double lane. Okay, now as Zen has already given the example of the Rifa clock tower roundabout, that roundabout has how many lanes? Yes, how many lanes do we have on this Rifa clock tower roundabout? So it's not single lane or double lane. But if you can go into the design standards, you will not find a 3-lane roundabout there. Okay, these slides are from a different book. The one which I used in traffic course is different, and the one which Dr. Rashid is using for the highway course is different. But in all these books, you will find the common thing is that the roundabouts are single or double lanes. So three-lane roundabout is a rare thing which we use here in Bahrain, and they have their own design standards for that. Okay, but for single lane, double lane, you will find many standards. Okay, and this is for the conditions to use these roundabout. So you can see two curves here, and then the graph is also divided vertically. Okay, so if you are in this side of the curve, should use single lane, and this side of the curve you use double lane. If you are here throughout, okay, so this is for all of it, you use double lane. So under the curve, under this curve, you can have single lane and double lane depending upon left turn percentage volume. If you are here over this curve, it is double lane roundabout. Okay. Now left turning percentage, we are using left turning percentage. This is AADT, average annual daily traffic. Okay, the average annual daily traffic. We haven't used it in this course, but we use it in the traffic course, so I will write it over here for, but maybe you have heard about it in the highway course. Average annual daily traffic. So if you take the average of the whole year, how much per day traffic you will have, that is AADT. And from this traffic, from AADT, what is the percentage of left turning from all directions? Okay, so some people will be turning left from west, some turning left from east, some from north, some from south. You will take their number and you will divide by the total AADT. This will give you the left turning percentage. And then you insert in the graph to know whether you should go for a single lane roundabout or double lane roundabout. So for example, if you look at this one here, okay, now this is for the peak hour. Okay, this is for the peak hour, so it's hourly volume, it's not daily. But if you have peak hour, you can use an approximate factor of 10% to convert peak hour into ADT. Okay, first of all, I want to know the total of the traffic on the intersection. So how much total traffic on the intersection I have? Tell me, what is the total of this table? So you need to add all the numbers which you see in the table. Okay, so this is for 1 hour. If you want ADT, usually a factor between 10 to 12% is used. So this is, let's say if you are using a factor of 10%, so we'll assume this is 10% of the total. Total is ADT, so 10% of ADT. So if this is 10% of ADT, then ADT will be this much. Okay, I'll divide by 10% because I want the total ADT. How much is that? Okay, so this is per day now, and as I said, this can be 10%, 11%, 12%. This is the normal range. Then I need to find out the percentage of left turning. So what is the total of left turning movement here? What is the total of this column? The left turning column. Okay, so now the percentage, because this is hourly, I will calculate the percentage from hourly as well. So percentage left turning will be 582 divided by 2153. Okay, hourly to hourly. How much is that? Okay, so now I have ADT and I have the percentage of left turning. Percentage left turning 27%, somewhere here, and the volume 21,000 something, right? So I'm here. Okay, so if I meet them, I come here. Okay, so this is the for the double lane. So if you are on this side, double lane. If you are in this side, double lane. Only this small portion is single lane. Okay, so and then you have uh, these two. There's a small curve here as well, but both of them are for single lane. In the first case, they are saying you can use a single lane roundabout, but monitor it, and this one is saying okay, single lane roundabout will work without any problems. So there's more confidence here and there's less confidence here, but both of them, the recommendation is single lane, but in our case the recommendation is a double lane roundabout. Okay, any problem, any questions? Clear, everybody? Zainab, Dana, Zainab Ali, everybody is clear?
Yes.
Okay, thank you. So I will stop here. I will not go on because